Alright, are we live? Let's see, I think so. So, hello. Hello world. Let me, okay. I don't know if this is gonna, I don't know what the connection to the stream is. Where's the live stream though? Excuse me. Just give me a minute. Trying to figure this out. So if I go here, all right. So this is a little awkward, but this is very awkward. Okay, so that's that. Okay, yeah. So we're here. Hi everybody. Sorry, not the best, but the question. So get right into the question. 145 binary tree postorder traversal. Given the root of a binary tree, return the postorder traversal its node values. So this is a pretty standard question. Number of nodes, node value. Recursive is trivial. You do it iteratively. So right, the recursive solution is trivial. True. I'm not even sure how I'd want to do it iteratively. But let's write the recursive version of it first. So postorder means traverse the left hand side, traverse the right hand side, and then operate on the root. So we'll write a routine. If I remember how to do this, it's been a while. Excuse me. So we'll just call it curse, and we'll use a lambda expression, and we want root, and it's going to be root. Well, no. Doesn't need anything, right? It's been a while. Please forgive me. I thought this was maybe a good place to start, something trivial. Okay. So what you do is you say return the postorder traversal. Okay, so we have this. And let's just say, we'll just take the whole context. Don't need the whole context. And we're going to say, now this is kind of interesting. F of root left of root right, and then ret dot push back root value, and we have the base case, if not root, return. Yeah. Something like this should do the trick. Yeah. Let's go for it. See what happens. Okay, got it. So, it's a quick explanation. This is a Lambda function. This will automatically figure out sort of what the types of the Lambda function need to be. This will figure out the in order to make it recursive, the Lambda function, what kind of function we need to pass to it, and what you do is you just pass itself as a parameter, right? And you just have to make sure that you continue to pass itself so it can keep calling itself. And then we have this sort of something of a, it's a local variable, but it's sort of global. It's scoped inside of, we add it to the scope of the Lambda function. And so then we push the values there, and that works nicely. What we want to do is, what is the question is, what is the iterative way to do this? Iterative. Let me think about that for a minute. That's not the most obvious thing. The iterative approach would be what? Postorder traversal. That's kind of challenging. What does the postorder traversal look like? It looks like the root node is all the way to the right. If you print it out, it looks like, let's get paint out here. The root node is all the way to the right. So we had, like, I don't know, just 1, 2, 3, 4, 5, 6, 7, 8. Oh, that's not okay. 8, 9, 10, 11, 12, 13, 14. Postorder traversal, the root node would be all the way to the right. And then you have these sort of two blocks set up, left and right. Now, since you process the left side first, you would do the postorder traversal for the left side. So the left side would be here, and then the right side would be here. You do the same thing again. So postorder left side is here, right? Left side is here. So 8, 9, right? 2, 4. Oh yeah, there's a 5 here. It would be left and then right, and then looks like this. And then 6, 12, 13, 6 should be here. And then 14, 15. Just move the 7 over. And then we would have 14, 15, 7. This is what the postorder traversal would look like for. Now, the way to do this iteratively, what you can do, I don't know if you can do it that way. I want to say you can do a pre-order traversal and then just reverse it. I don't think that's true though. Pre-order traversal looks similar. I don't think it's reversed though. That would be kind of funny. Do an iterative pre-order traversal and then reverse. That would be kind of funny. That would be interesting. Pre-order traversal 1 left side, 2 left side, 4, 8, 9 right side, 5, 10, 11. I don't think it's true though. No, it's not. Immediately you can see it's not true. That won't work because it's a just thinking, is a pre-order traversal, I have an idea of how to do it iteratively. I don't actually know how you do a post-order iteratively. That sounds interesting. I feel like I should know how to do that. Oh, just offhand. I want to say you would reverse at each step. So do a pre-order. No, that seems so bad. No, that doesn't really. Let me think about this here. Postorder traversal is kind of interesting. It's this, so what it looks like is, I really gotta think about this, huh? This, 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 and then repeats here. How would you do that iteratively? Oh, I don't know, man. I don't know. My first guess, I don't know. Huh. Huh. Well, this is the leftmost node down here, and then you go up one, you go up to the parent, and then take the leftmost node of, I guess, the right subtree, and then I think I remember implementing something for this. It was pretty wonky though. It was pretty like involved. I think I remember doing this question once before. I didn't like it. I didn't like it. I'm wondering if you can do a version of breadth first search as well. I don't think so, no. No, it doesn't work like that. No. I mean, it would be iterative if you could implement breadth first search here. However, there's a few problems. One, you use extra memory doing that, and two, you use more memory than you need, and two, I'm actually wondering if you could use a double-ended queue and put this on the end of the queue, push this on the back of the queue, and then push the two children left and right on the front. So you put the right child, or just a queue. You could do it that way, actually. What do? You do the left child, the right child, and the parent. It should be the order that they get processed in the queue. When you process that node. That's a little funky. It's a little weird. I'm pretty sure you could do this with a queue, doing a modified version of a breadth first search. So you would push this node to be processed. So it's not a stack, it's a queue. You would push queues the stack. So the deal with the stack is the last thing you push on the stack is at the top of the stack. The thing with the queue is the first thing you put in is at the end of the queue. Excuse me. No. A queue is like a line, so you'd put like a 1, 2, 3 is not what you want. What you'd want to do is put 2, 3, 1 in the queue. And you also maybe want to have a flag basically a Boolean that could just be like, you know, processed or something. And what you're going to do is when you come across 2, you then, it's not processed, right? So then you push onto the queue. Now, you would want a double-ended queue, really. Yeah, you'd want to push to the front of the queue. You'd want to push 4, 5, 3, 1. And the 2 goes where? The 2 becomes processed, and you actually want 4, 5, 2 right in that spot. Right? And then 4, yeah, this would actually process correctly. This would do it, I think. And then 4, you would end up with 8, 9, right? And 4 is now processed. 2 is processed. 3 is not. 1 is processed. And then 8 and 9 don't have any leaf nodes, so they become processed too. Or 8 becomes processed, and then you actually pull 8 off. And then 9, same thing, doesn't have leaf nodes, becomes processed. You pull it off, pull off 4, this is processed. 5, then you end up in this state. 5, 2, 3, 1. And then 5, you can process it and get 10 and 11. And you have a similar kind of thing going on. Yeah, that's one way of doing it. I like that. That's not great, but it's doable. We'll go with that, I think. We'll go with that. Let me see if I can code that up. So yeah, modified version of breadth first search. Please don't mind my market. The market's going nuts because of Trump. Trump talking about the stimulus, pulling out of the stimulus deals, going toward the stimulus deals, all that stuff. It's like the market's just all over the place. Anyway, yeah, so that's one way of doing this. Let's save this. All right. Where do I want to save it? Yeah. What does it say? Binary tree post order traversal 145 1. So this is one way of doing it, and then there's another way of doing this, which we'll call 2. So we're gonna have our double-ended queue or deck in C++. I don't remember all of the ways to do this. Or use a tuple as well. Let's see why, or a pair we'll use. And we have push back, pop back, push front, pop front. Right, that's really all we need. And we're gonna have not integers here, but we're gonna have a pair, and it's gonna be of a tree node and an integer boolean. They have bools in C++. C++, right? I think so. And it's going to be Q. We'll just call it Q. And we're going to say while Q. I guess. Yeah, I think Q will give you not empty. Or we'll just say while Q, well, not Q is empty. Right? And we'll start by pushing into the queue can I do it this way? Make pair of the root and false, so not processed. And we're going to say, now can I use destructuring syntax? Let me see. I think I can. I could try it. Auto XY, that's kind of fun. Huh. Auto ABC equals tuple. Alright, let's give it a shot. So it's going to auto node and processed equals q dot pop front. We want to see front and back. So pop, is that right? Yeah, pop front, pop back. So we pop the front. Now, what's interesting about this is, right, we're going to push all the things back on. We actually, this could be done with a stack then, I think. Now I'm thinking about it. I don't think I would need to use a queue. So it's not processed. Then we say, well, we're not empty. We're going to say queue front. We're going to say queue dot push front. You're going to push a few different things onto the front. We do this. We say if processed, then ret dot push back node value, and then otherwise do these other things. I want to say, oh, and pop front. I mean, you always pop the front. Oh, no, you don't necessarily pop the front, actually. Yeah, I guess you do pop the front in every case. I guess that's true. You do always pop the front. So first we push node left, and it's going to be standard make pair of node left. Now we want to say if node left, push it on, and same thing if node right. Now I'm wondering if there's a better way. Hold on, because I'm wondering if there's a way. Yeah, I mean, if there is a left node, you want to push it. If there is no left node, you don't do anything. Same thing with the right node. Now the question here, yeah, that's fine. I mean, I was thinking maybe there's a way that I could include this, like with a breadth first search. You know, this is sort of something you would do on all of each of the node paths. I guess you would sort of do the same thing, but I'm wondering if I could put the, like, if there's not a, basically if there's no, if the node is null, then we would just continue, you know, instead of doing the checks here. But I don't mind doing the checks here. I think it's okay. It's a little bit of duplicate code, I guess. I think it's fine. So node left, processed false, and then we'll say process true. And this is not going to be node left. This is actually going to be the same node, but this time true. And these are missing parentheses. Right. So process left, process right. And then also, now we actually want to put, we actually want to push this thing first. This is why I'm saying we could use a stack for this, I think. We want to push this first, and then the right side, so actually pushing everything in backwards. Pushing everything into the stack backwards. Yeah, kind of interesting. What happens if we do this? Expected, oh yeah. Probably could, you could like do this, you know, keep things a little more clear. Declaration of variable node, two-step one requires. I wonder also if you could do this guy. Is this how you do destructuring? Hey, it works. Is it correct? I don't know. I mean, I should run some test cases before I just throw it in there. Let's go for it. Of course. Oh, really? How's that happen? Oh, no. Huh. Really? What is this test case? Oh, gotcha. Interesting. Yeah, I didn't think about that if the root node is empty. Alright, fine. So it was better to do this then. Skip null nodes. And then you don't need to check this at all. Yeah, you know, I didn't realize that. Okay, lesson learned. That it's actually better to do it the way that I was going to do it before, this way, because it handles a null root node. Interesting. Actually, you do both, I think. Very interesting. Let's see if we miss any test cases. Oh, got it. Wow! 0 milliseconds. Faster than 100% of other submissions. No kidding. No kidding. There you go. That's one way to do this. And this doesn't need to be a deck either. This could be just a standard array, or not array, stack. Well, really you could make this a vector even. And push back, pop back. Let's try that. Let's see what happens if we do this. We use an array rather than a deck. Is it still the same thing? Yep. There you go. So that's one way of doing this iteratively. It's not great, but you can do it this way too. Interesting. Very interesting. I'm wondering if you need this processed stuff going on. Yeah, I guess you kind of should, kind of can, kind of could. I think it's interesting. I like this. I like this approach. Root false. I'm just thinking about this here. It's pretty fast. It's pretty fast. It's faster than everything else. It's pretty fast. Gee. It does use extra memory though. There's probably a way to do this that doesn't use extra memory. I don't know it offhand. To do it iteratively without using extra memory. This is iterative, but it's like sort of iterative because we're still using a stack. The previous approach uses the call stack. I'm wondering. Yeah, I think you got to do it this way, or at least this is I like this way. I like this approach. This still makes use of a stack, though. That's the thing. There might be a way to do this iteratively that doesn't use a stack. Let me think about that for a minute before I move on. I don't know. Post-order traversal is kind of tricky. I know how it would do in order. You can use what's called threaded trees and a Morris traversal. And then a Morris traversal. I don't want to spend too much time on this. Morris pre-order. You can do pre-order or in order. I'm not sure if we do post-order. Morris traversal. Okay. So you can use a threaded binary tree, which basically takes your basically creates threads back to the parent nodes. You can go the other direction too, this way. And that's what a threaded binary tree is, and you use a threaded binary tree, or one use case is for Morris traversal, which is, please tell me somewhere you have Morris in order using threading, right? So Morris in order traversal can avoid recursion, and you don't really use much more data. You don't really, technically don't use any more memory than you've already sort of allocated for the tree. I realize this is a bit silly, kind of trying to optimize on the memory, because technically the memory to even store the tree in the first place is linear anyway, so we're not really using that much more memory realistically. But we want to use constant additional memory, which, I mean, it makes a difference, but if we can. The tricky thing here is you can do, I'm pretty sure you can do in order using Moore's traversal. Pre-order using Moore's traversal, I think, can also be done. Yeah. I think pre-order, what do? You do the root, print, save the root, go down the left subtree. I'm actually not even sure. How would you do the pre-order or the post-order? Using, they're both really similar. I think actually if you could do either the pre-order or the post-order using, without using using constant extra memory, then I think you can do both of them, possibly. I don't know. The pre-order seems like it's easier because you can, I don't know, man. Iterative implementation, you can remove the static requirement, taking parent pointers in each node, or by threading the tree. Is that what we gotta do? Yeah. Well, what did we do in these cases? Iterative post order, iterative in order, iterative pre-order. I feel like I'm cheating looking at this now. Huh. These are probably similar. Yeah, with a stack, it's kind of trivial with the stack even still. It's not trivial with it's not trivial with I guess it's not that complicated if you thread the tree. What do you do if you thread the tree then? For all cases, I guess. What would it look like? What would it look like? I guess it would be for post order. You don't want to use a stack, right? So you go down to the left, all the way to the left side, process that node, then follow up to the parent. Then process the right subtree of the parent. I guess, whatever that means. Do that. And then, which is basically just continue iterating, I suppose. And then you're gonna sort of continue the algorithm, so to speak. And then return to that parent again. And then, process that parent. I guess I'm gonna go to that node's parent. You might, no, you still need a stack if you do that. I guess you would need to thread both directions. You can thread both directions, basically the leaf nodes would have threads, I think. I think it's leaf nodes that have the threads. Do you have to thread in both directions to do the pre-order traversal, the post-order traversal? It doesn't seem right to me. You would process this right subtree. And yeah, you would need to go back to the parent. Oh, this 8 doesn't need to go to the parent. It just goes. Huh. Processing this left subtree, you then need to go to the right subtree. You can use the thread to do that. Process the right subtree. However, you don't want to go towards. You actually could get this parent again with just a right thread, because you can right thread up. You can make like a circle. I think I've actually implemented this before, but yeah, you basically left subtree, go to the parent, right subtree, go to the parent's parent, and come back down. Yeah. Is this always? Yeah, this will always go one level above, right? This, right? It must. I think so, and then it's the left. Then you just take the left child and process it, and then, you know, continue from here, and now you've done the left subtree. I do this right subtree. The same thing. This parent, come back. I think that works. I think you have to just prove that this thread back to this child is what you want. I think you can do that in theory. I want to say that's the way to do it. I want to say it's that simple. I realize on the wiki page it makes it seem really, really simple to do this. However, it's not so obvious to me. Not the simplest thing to me. But yeah, I won't code that up though. Won't go that far. We'll just stick with that it could be done. I think it could be. May not be perfect, but it could be. I might want to go to the solutions here. Yeah. 145. We'll do 3, we'll say. All right, that's probably it for, actually it didn't need to be 3, but we can just, that's okay, it's fine. We'll leave it as is. That's probably it for this problem. We just think, pretty interesting. Yeah, I guess we would want to look at the solutions too, as well. DFS, BFS. Recursive post order. Right, fair enough. iterative pre-order, tweak the order of the output. Yeah, I have to keep the stack still. Interesting, use the iterative pre-order. I actually didn't do it that way. I did it slightly differently. Oh, push left foot, no, wait. Oh, I think. Yeah, you reverse the output. Yeah, I was gonna say you can reverse. Really, is it just the reverse of the pre-order? Is that true? Yeah, this pushes to the front rather than pushes to the back here. This is going to append and then you reverse at the end of the loop. Interesting. That's super interesting. I like that. Just do a pre-order and then reverse it. Iterative post order. Interesting. Nice. Why is this hard? They didn't mention the discussion would probably mention the post order. Not the post order, the threading. Anyway, okay. We don't have to spend that much time. All right, so that's that problem. So yeah, thank you all for watching, and we'll go ahead and we'll stop the stream, stop the recording, and I actually think that's gonna be it for tonight. Yeah. So thank you all for watching. Talk to you soon. Have a good rest of your night. I'll just stop the recording altogether here. I think. Just stop in the stream, go to bed. But what I would do next is I would stop the stream and start another problem and stream and start a new stream with that, and that would just be like the video each time. Okay, yeah. Take care.